So now we want to look at concurrent collections. We saw that ArrayList is not thread safe, together with some others like hash maps, but we do have other variants of thread safe collections like CopyOnWriteArrayList is thread safe, concurrent hash maps and the likes. So we see that, as we mentioned, that methods such as remove, add can throw concurrent modification exception if another thread modifies the array list while another is accessing it. So however, methods in the copy and write do not. So as you can see that if you go into the Java docs, it will tell you that a copy on write array list is a thread safe variant of array list in which all mutative operations are implemented by making a fresh copy of the underlying array. We know that an array list under the hood it uses an array. So let's look at this in practice. So we are going to start with an array list. It can be a linked list or whatever, and what we want to do is we want to modify this while we are busy iterating it. We want to modify it while we are busy iterating. So let's run this code and observe what happens. We see that we get concurrent modification exception. So let's try to do this first. So let's say list iterator dot for each remaining. So what we can do here, since this is lambda, we are still going to look at lambda expression. We can just okay, it's a consumer, it has to get something. We can call it x, and that x is a string. So what we can do, we can say list okay, iterator dot remove. So let's try and run this code. We will undo whatever we wanted to do. We see that we also get this exception. Let's say, can we have something like, what else can we do in here? I want us to, okay, it's fine. We can leave that for now. Let's go back to the example that we had. So what we have to understand is that iterators of list unthread safe, like linked list. Okay, let's put array list here and run this code. See that we also get, because they are iterators, are not thread safe, they will not allow you to perform this operation. You are still accessing it, but at the same time you want to add something on it. So now let's start with the copy on write array list. We see that we have this here. So this is exactly what I wanted to do. So before I come here, instead of using a for each like this, let's use an iterator. So we see that this iterator, when it senses, like during iteration, when it senses that the list has changed, it throws a concurrent modification exception because it senses it has changed. So let's do a linked list. We still get the same problem. Let's try to use this copy on write array list and see what happens. We see that we even get a 4 here, like 3 times, because we have the elements here added 3 times. So let's say 5. We have it added 4 times. Why? Because as you saw in the slides, the mutative operations are implemented by making a fresh copy of an underlying array. So a new copy gets created. So let's say that in practice. So what I'm going to do, I'm going to observe this, and then we want to see the add method. So as you can see, this add method is even synchronized. And we see what they are doing here. You get the underlying array, you check the length, then you create a copy of it, and then you add a new element that you need to add. Then you return, you set whatever you need to do, you set true. Let's look at what we have in the linked list. You see that here we don't have a copy as we are doing in here. This is where the issue comes in. The same goes for concurrent copy on write array set. If we run this, we are not going to have a problem because it's thread safe. And what we see here is that 4 only appears 1 time, and anyone can guess why is the case. We see that in here we have 4 appearing 4 times, but when here we have it appearing just 1 time. This is because it now comes back to, we are going to look at this when we work on collection. A set maintains a list of unique values. So you cannot have 4 added more than once in a set. But in a list, it can appear as many times as you want. That's about it with this concurrent collection. We are still going to look at more of collections in our lecture on collections. So this ones, we only had to work with them because they had to deal with threads and thread safety.